There is another concept that you need to master. And if you heard about converged access, you may have heard about scary stories about this concept. But it's not that scary if you just understand what it does. And actually, it's not only in converged access. It's the concept of mobility agent and mobility controller. Mobility agent, to make it very simple, is the point to where your access point connects. So you see here, you have the CAP/WAP control traffic coming from that access point and ending on that controller on the right side. Well, just because of that, because the AP is controlled by that controller is the mobility agent. You will also see a definition of mobility agent that says it's the first controller of entry of client traffic into the network, which means the same, right? Meaning that your client traffic is going to go from the client to the access point and is going to be encapsulated into CAP/WAP and then sent to the controller on the right. And because it's the first controller hit, because it's the controller that manages that access point, it's called the mobility agent. So just seeing the mobility agent at the point where the CAP/WAP control tunnel ends, or the first point of entry of client traffic into the network, is basically talking of the same place, the mobility agent. But there is also something else which is called the mobility controller, and that's also a function. And here, instead of just talking about where the access point terminates its CAP/WAP tunnel, what we're talking about is roaming. And what we're saying is, if your client moves from one access point to the other, something has to be aware of that in the infrastructure to make sure that the client traffic doesn't stop, that the client session doesn't end, that the client doesn't have to redo everything from scratch. So we have to work in the infrastructure level to make that transition smooth and seamless for the client. The entity that is in charge of that is what we call the mobility controller. It's handling mobility. In most cases, it's a controller somewhere. It could be also the same place as the mobility agent or not. It depends pretty much on where you want that control of mobility action to happen. This is an important place for clients because this is where you will have a central view of client movements. And this is important because you want to have consistency in the client policies. So you will have here the PMK, but also the QoS and the security policies. I need to be able to forward those as the client moves so that the client context doesn't change as it moves from one AP to the other. It can still access the same resources, it still has the same QoS policies, etc. So having a place where all these are stored and managed is key to successful roaming. By the way, the mobility controller doesn't have to be one single controller to where all the access points are attached, right? Remember, the point where the access point attached is the mobility agent. The mobility controller is the one that controls the central place where that client's context is known and forwarded. So you may have one AP connecting, for example, to that MC here, and you may have the other access point in my example managed by another controller, and yet you may still have one of these controllers being the mobility controller. What is important is that when you move from one AP to the other, there is that place that knows about you, that knows about your context, and that is able to forward to wherever is needed the context about what the client is, what kind of security and what QoS is needed on that client. So let's talk about architectures here and operating systems. We have basically two types of operating systems in a Cisco wireless world, AirOS and iOS XE. In AirOS, every controller is both mobility agent and mobility controller. They are appliances, virtual or physical, which means that access points are going to be connecting to an appliance, virtual or physical. Therefore, that place is going to be the mobility agent. And all clients connecting through these access points are going to connect through that controller, and therefore that controller is going to be the MC for those clients. And as the client moves from one controller to the other, they are going to move the context from one controller to the other, and each controller is going to behave both as the MA and as the MC. Now, if you look at iOS XE, because you can bring the switch to be a controller, you can also split the MC and MA function. So of course, because the access points connect to the switch directly, well, that is going to be an MA. But it doesn't have to be an MC. It can, but it doesn't have to. Maybe you want to have one appliance somewhere in your network that is going to be behaving as the MC, while the switch is only going to be the MA. That's a choice you make in your design. The result is that the AP connects to that MA and the client traffic goes through that MA, but there is that central appliance that knows about all the clients on all the switches and that is able to pass around client context to whoever needs it so that the client roaming can be a seamless experience. By the way, that MC can be an iOS XE box or can be an AirOS box. You decide. You can mix and match the architectures, although in most cases, we recommend not to mix them, except if you are in migration mode from one to the other. But there is compatibility between these two, and that's something as a CCNA Wireless that you need to be aware of, and I'll show you how we configure that. The combinations can be a little bit complex, where you may have some devices that are converged access iOS XE switches that are MAs, some others may be converged access switches and they are iOS XE and they are MA and MC. And then you may have some AirOS devices that are by default MA and MC, they cannot split these two together. So you can have some very complex combinations there where you have a mix and match of different architectures, different operating systems, and different roles. But what is key for you as a CCNA is to understand the role, MA as being this connection point to the client or the access points, and MC being this point where the client context is known so that seamless roaming can happen.